Hi, and welcome back to Neil's Notes. In this video, I'm going to walk through how to get a camera working on a Raspberry Pi using .NET and C#. And as always, I have a set of notes that you can follow along that are available here on neilsnotes.net, and if you scroll down and look at the contents, you can see .NET camera on a Raspberry Pi, and this is the set of notes that I made that accompany this video to walk through how to get a camera working on a Raspberry Pi using C# and .NET 6. So let's get this out of the way and let's get started. To use the camera on a Raspberry Pi, you're going to need to enable, let's just zoom this in a little bit to make it easier to see, maybe one more time. You're going to need to enable the camera, and depending on what hardware you have, most of the hardware that's out there will be what's called a legacy camera. So we're going to need to enable the support on a Raspberry Pi for legacy camera. And if you run raspi config, you'll need to do it as super user, so sudo raspi config, and go to the interface options, that's number 3. You'll see a legacy camera enable disable. Now most of the cameras that you probably have out there, certainly if you're working in a school or a classroom, will probably be classified as a legacy camera, and you'll need to make sure yes is selected and legacy camera support is now enabled. So that's the first thing. To use the camera, you're going to need to install some libraries. Let's get started installing the first library that we want. So we're going to get and install v4l, so that's an L, not a 1. And again, these are all in the notes, utils. And actually this Pi should probably already have them installed because I've been testing this on this Pi. And then we want to install the C library for development. And there's a few here, and let me just make sure I haven't got any typos here. So yes, and the X11 library for development, and it will go ahead and actually it tells me I've already got all the latest versions of those installed on my machine. Great. Once you've got the libraries installed, we need to create a place to put the code that we're going to build. And if you've been following the previous few videos, you will have noticed that I have a dev folder in my documents folder, which is where I like to put all the code relating to the different projects. If you don't have one, you'll need to do something like make directory dev to place your code. And then once you've done that, we want to create a folder for the camera code that we're going to write. So we could do make directory .NET PiCam, because we're going to do a .NET program to access the Raspberry Pi camera. And then we could cd to that directory. So now we have a folder in order to create our application in. We need to actually create a template for the application. And again, if you followed previous videos, it's pretty straightforward. We're just going to create a console application in this folder and away it goes, creates the console application in .NET Pi, and we can see it's created the main program CS file and a CS proj file, which we can now open in Visual Studio Code, which should make our lives a little bit easier to do the development. To access the camera and actually other accessories attached to a Raspberry Pi, you're going to need to use some libraries. Now, the libraries I use are the Microsoft IoT libraries, so we're going to import those into our project. So let's create an item group to bring those new packages. These are NuGet packages that we can import into our project, and they contain the libraries that we need to. So package reference, that is a reference to a NuGet package. We will include and then the name of the library. So for this package reference, we're going to include system.device.gpio, and that lets us access the main I/O ports on a Raspberry Pi. We'll grab version 2 of the libraries, which just recently came out. And then we're going to need another package, so I'm just going to copy paste that and change the package name. And this one is the IoT device bindings. And again, version 2. And this will let us access the different capabilities on the device. So we now are including these NuGet packages, and that'll pull down the libraries, the .NET libraries that we need in order to code our .NET application to access the camera. So let's go across to the program file, and let's just get rid of all of this, and we're going to start writing some code to access the camera. The first thing we're going to do is import that IoT device media namespace that comes from one of the libraries that we just added to the project. And then let's just let the person running this application know what we're doing. So we're going to just put a little message out that says getting information about your camera. And this is going to take a bit of time. We'll do ... Great. Then we're going to create a new object called a video connection settings, which we'll just call settings in our application locally, and we'll do something like new video connection settings, and that takes some parameters. The first parameter it takes is what they call a bus ID, and this is the bus. If you know how hardware works, it often works by all the different connections are often called buses, and so you can have different connection numbers, and we're going to start by just looking at bus ID 0, and then what we want to get out of this is what size we can capture our images in. So if you've got a reasonably new camera, you can probably try and capture something like 2592 by 1944, and that would be a default capture size. And then pixel format is what format you want to capture the video or the images in, and there's a enumerated type called pixel format, which we can select JPEG from. So this is setting up some basic default settings for our connection, and then we want to actually use those settings to create a video device. So we're going to do something called using video device, which we will just call device equals video device create. So it has a create method as a static, which means you don't need to instantiate it, but it will create an instance of a video device using those settings. Now, by adding the using at the front, it means that when this goes out of scope, it gets disposed, which means the memory gets cleared up and anything that it's using should be freed up for use back in the Raspberry Pi. Then we're going to create IEnumerable, and this is an IEnumerable of pixel format. What we want to do here is get a list of all the different formats that this camera can support. So we'll say our formats equals the device get supported pixel formats. So now we should be getting a list of all the different formats that this camera attached to the Raspberry Pi can support. We could actually do something simple where we just, for every format in formats, we can output a list or information about that format. So we'll do something like console, write line, would be good to know what this format is called, so pixel format with information about the format. So the format itself is coming back to us, and we're going to output that as a string here. And then what we want to get from that is a list of the resolutions that are supported. So we'll do an IEnumerable resolution, which will be a list of the resolutions, and we'll ask the device to get pixel format resolutions for this format. So now we've got a list of resolutions, we should probably list out the resolutions. And actually the first thing you might want to do is just check that there are any resolutions at all. So if it's not null, because it's possible that it could return I don't support any resolutions in this format, and therefore there would be nothing to output. So we could do for each res in resolutions, let's console write line, and at this point we will do the in fact we'll just put a little bit of space in there so that it's the resolution, and then underneath it tabbed in will be the min and the max resolution. So we'll go min resolution, and we'll do something like res dot min width, and that's going to be by the res dot min height. So now we've got this minimum resolution being output, we could do exactly the same for the maximum resolution. So this would just be max width and max height. Okay, so now this piece of code should look at the camera, interrogate it for the supported pixel formats, get the resolutions supported by each format, and output the minimum resolution and the maximum resolution. To run this, we can open a terminal here in VS Code. Give us a little bit more space maybe. And .NET run. Should compile. And then look at the device that we're currently working with and give us a list of the different formats and different resolutions. Taking a little bit of time to compile. And there we go. So it's quite a big list, and you can see all the different formats. So it's getting information about your camera, and it's getting, well, it looks like most of the formats are, the minimum is 32 by 32, in fact all of them, and the maximum is 2592 by 1944. Now your camera, if you're doing this on a different Raspberry Pi or different camera, could be different. So these may not always be the same. This is the camera that I've got plugged into my Raspberry Pi right now, but of course yours might be a bit different. What we now know is that the camera is attached and it's functioning because it's given us some information. So to capture an image from the camera is actually very simple, and we could do that by getting rid of a whole bunch of this code and put something like console.writeLine smile, you are on camera. And we're no longer getting information about our camera, so we can take that away. And then in order to capture an image from your camera, it's as simple as calling the capture method and then passing in a place to store that image. So you're going to want the folder. So in this case I'm going to put it into my pictures folder, and I'm going to add, I guess you could add a different folder in here if you want, but let's just capture JPEG. Oops. So that'll be the image that we capture, and it's that simple. So this should now create the camera device, capture an image, and then exit. So let's run that. We'll go down here, type .NET run, and I put my hand in front of the camera, and let's see if it captures an image of my hand. So let's have a look in our pictures folder. There's our capture, and there's my hand in front of the camera, and you can see my keyboard and screen behind it. So that's working. So now we have captured an image on the camera, and that was very, very simple. Look how little code is required. Capturing a single image can be useful sometimes. However, often you're probably going to want to capture either a whole series of images, like a time-lapse type deal, or a video. So let's start by changing this to capture a series of images. I'm going to reduce the resolution to 640 by 480 just because I don't want to take up a huge amount of space in the on the memory card of the Raspberry Pi to capture all these different frames that we're going to capture. But of course you can, if you've got a bigger storage space on your Raspberry Pi, you can. Just be warned that of course they get pretty big pretty quickly, these images. Now if we're going to capture frames that we're catching from the camera, we should probably track how many frames. So let's create a local variable called frame, which captures the number of frames we've got. And then we're creating the video device. That's all good. What we want to do now is set up a event handler, so this device can tell us whenever a new image is available on the camera, and that's called a new image buffer is ready. And we're going to add to the we're going to add an event handler for whenever that event is raised. So whenever there's a new image raised or available, we're going to grab it. So let's create a new image buffer ready event handler. Of course you can call this anything you want, it's just a method that we're going to write in a minute, and then we can start capturing images from the device. So we're going to call start capture continuous. So we're going to continually capture images until for something we say okay, stop. And in order to stop, we're going to need what's called a cancellation token. So a cancellation token, which we'll just call our token source. It can be called anything you want again. New cancellation, that should be a token. Actually it should be a cancellation token source, so let's just cancellation token source, let's fix that. So here's our token source, or our cancel token, and then we could use threading to do this. There's probably a number of other ways, but we're just going to create a new thread. And a thread, so in your program you can have, so far everything we've looked at in this series of videos has really been one thread just running. That's not strictly true because we've used tasks, but basically it's been one thread that's running and it's just continually going through. Here we're going to split off and we're going to create a separate thread. So the illusion is that there's 2 or 3, every thread has something running in parallel. Now depending on your processor, that may be actually true, or it may be time slicing between the threads and swapping in and out. So we're going to create a thread that's going to run this capture continuous. Whoops, it's good to get the spelling right. Capture continuous with that token source, so with that token and the actual token that's in it. So we're going to start capturing everything, and we'll actually get that thread started straight away. So we're creating a new thread and we're starting it. Now at this point we probably want to let whoever's running this application know that we are capturing video. Press any key to stop. So we're going to have to capture a key input to stop this video continuing. But while console.log key available is false. So while there's no key available, we will just sit here and spin for a bit. So we're just going to do nothing on this other thread. We're just going to keep looking for a key being pushed. Now when a key is pushed, we can then use our token source to flag that we want to cancel any more action that's attached to this, and in this case the action is capturing continuously. So by calling token source cancel, it'll stop this thread and this thread will exit. And then at that point we want to do something like device stop capture continuous to switch off. So we started the capture continuous. We had a thread that was capturing these images from the camera. When someone pushes a button, any key on the keyboard, it'll cancel that from capturing, and then we'll stop, which will close the camera down and stop it from doing anything. The next thing we need to do is actually write the event handler that we set up here. So this new image buffer ready event handler, we're going to need to write the code for that. And that takes an object which is the sender, so the thing that's sending the event, and it takes a new image buffer ready event args. Now these event args are going to contain some information about the image buffer and what it contains. And we're going to create a try catch loop, and we'll talk more about that in a minute, but essentially what this lets us do is it lets us determine whether or not the code in here is working, and if it's not, if something fails, it'll throw an exception, but in this scenario we will capture that exception. And actually the exception we know we're probably likely to get is an object disposed exception, because if the camera has stopped being used and the image buffer event handler hasn't caught up with that yet, then we won't be able to get anything out of the camera because it will have already been disposed or cleaned up. And if that does happen, well, in this program we're actually not going to do anything, so we're going to just put a little comment to say ignore this for now as it is expected when the camera stream is stopped. Okay, so now we need to do something with the image that we've got, and we're going to write out the file name, or we're going to write out the file into a file, the image buffer. So we've captured an image buffer, but that image buffer, if you remember up here, contains a JPEG that's 640 by 480, and every time the camera has another image ready, it calls this event, and on this event we're going to save that image buffer to a file, and the file we'll save it to is going to be in our pictures. We'll create a folder called frames, and we will say it is frame. Now remember, we're capturing how many frames we're got up to, so we'll put a number after each frame so we know which frame it is. So we're going to save to that file the so the image buffer event args has an image buffer in it. So let's save that to the file with the frame name, and the frame name will include however many frames we've captured. Now, of course, what we're going to need to do here is increment. Now we've saved a frame, we need to increment the frame number, and actually every time we do this we could just write a dot onto the console, so that as you see the dots appearing on the console, you know you've captured frames. So every dot on the console as we run this should show a captured frame. So let's run this. Let's see what happens when we run this. And we could just run it from the console. So .NET Run. And if our code is doing what we expect it to be doing, then let me put my hand in front of the camera when it starts capturing and make some movements. We should get a whole bunch of images. There we go. So, and if I press a key to stop and then look in the frames, there's a whole bunch of frames. And if we look at frame 0, there's my hand. Frame 1, skip ahead. There we go, we can see some movement happening there. Yes, definitely. So we're capturing, the camera is capturing, it's probably a little, my hand is probably a little close, but there you go, I twisted my hand. But it's captured in that short period of time 30 frames from the camera using this code, and this code has gone through I guess capturing each frame as soon as it becomes available, saving it to a frame file or a JPEG file, and then doing the next one. And then as soon as I hit any key on the keyboard, it came out, cancelled, and stopped capturing. And you can actually see this because the light on the camera goes on while it's capturing and switches off when it's not capturing. That's kind of cool, but it's not really capturing a real video, is it? It's capturing all the frames that, yes, you could make into a video. What would be nicer would be to really capture a video, and I guess it would also be nice to get rid of typos, so capturing video. And so in order to do that, let's just start at the top again, and we're going to change the format that we're going to capture to capture a different format. In fact, this time we'll capture an MP4 format, and the MP4 format is 264. H264 is the name of the MP4 format. And now if we're going to capture real video, we actually don't need to start capturing the frame count, so we could get rid of this. We are going to need to create a video device, obviously, but what we can also do here is we can say using file stream. So a file stream is a way of writing to a file. Streaming is a way of serializing or streaming a whole set of bytes to a file. In fact, you don't just have to write stream to a file, you can stream to memory, you can stream anywhere, and it's really just a way of channeling a series of data bytes into the endpoint you're going to. And the endpoint for us here is a stream, and we're going to do that here with file create pi home. Let's put it in our videos folder this time rather than our pictures folder. Capture H264. We still want this image buffer ready, but instead of just saving files, we're going to start streaming into this video stream. So we're going to still want to capture continuous, and we're still going to want to have a way of cancelling it with a cancel token. And then we're again going to spin off this thread to start capturing, and again wait for a key input before we stop capturing. So that's all the same. The bit that's going to be different is here in our image async handler, we're going to need, or our image ready handler, we're going to need to make it asynchronous. It needs to support async because we're going to use a method that will write to the stream, so that file stream we just created. We're going to write the image buffer to that stream, and we will write from the 0th point of our image buffer to the length of our image buffer. And we really want the whole thing, is what we're saying, written out to the stream. We no longer need the frame incremented because we're not capturing frames anymore. We're actually capturing a real video, and that should be it. So let's go ahead and try running this again. Slight challenge here. It's telling us, and this is great, on line 9 the new image buffer ready event handler has the wrong return type. Now this is a little bit annoying because async methods should return a task, but actually because it's an event handler that's defined as void, it's going to say it's going to complain about it. So it's not ideal, but we can make this work. It won't find part of the path. So do we have a problem with not having a videos path here? There's videos, home pi videos. I did it the wrong way around. No wonder. So real-time debugging, all good, and these are things you're going to have potentially challenges with. So it's actually home/pi videos. We can just check whether there was another issue. Well, it can't open the file, so then from then onwards we're in trouble. So let's just go back, make sure that's saved, and then try running it again. And now I've got my hand moving, and let's see what that looks like in terms of the video that it's captured. So here it's captured a video, and I should be able to open that on my Raspberry Pi directly using something like, there we go. And that's actually a much nicer way of capturing than capturing the frames. You can see that working again. There's my hand moving on the video. Let's go back to the code. So a quick walk through the code that we've written, just to make sure we understand it. We're creating a video connection by using a set of settings. Here we're defining the size of the video and the pixel format that we want to capture in. We're creating a new video device object with those settings. We're then opening a file stream to write out the video to, setting up an event handler for every time there's an image buffer available to notify this event handler to write out to this file. Then we start capturing the video. We have a way of cancelling the capture. We spin off a thread that starts capturing with that token that lets us cancel, and then we wait for a key press. When we get the key press, we stop capturing, and we set the token to cancel. That will end this thread, and then we stop the capturing. In the event handler, it's very, very simple now. We're just writing each image buffer as it arrives into that file stream and adding a dot to the console. So every time there's a dot on the console, we're writing out one of these image buffers. And that's it. We now have video capture working on our Raspberry Pi. Thanks for following along on this video. Hopefully you learned something. We added a couple of libraries that Microsoft provides us, the IoT device bindings library, and that really makes it very simple for us to access devices attached to the Raspberry Pi or other IoT devices as well. Of course, the Raspberry Pi is the most accessible, and so we use that in this video. And underneath that, we also added another library, the System Device GPIO, and that's a lower level library that the device bindings library uses to access the hardware directly. This makes it very simple to get started building something like we did today, which is a camera application on a Raspberry Pi just driven from the console. I hope you learned something, and I hope you join me for the next video. Thanks for watching. Bye.